So it has to be an easier way. And that's where integration by substitution. Excuse me. If we let u equals x squared plus 1, what is the derivative of that? Excuse me. There we go again. What's the derivative of x squared plus 1? 2x. Or I can write du equals what? 2x times what? dx. Interesting. Look at this piece. Isn't that the same as this? Can you see that? So I can write that what? The integral. In place of tx dx, I'm going to put what? du. And what is x squared plus 1 equal to? Isn't that u? So I'm going to write that as u to the power of 50. Here's the good news, bad news, depends how you look at it. You cannot integrate if you have x squared du. None of us can integrate that one. These two have to be matching. So if you have u here, you better have u here. If you have x here, you better have x here. So now this matches. And because it matches, I can follow that rule which says add 1 to the power and divide by the new power. So if you add 1 to the power, what do you have? U to the 51 over what? 51 plus c. So that's 1 over 51. Here's the good news, bad news again. When I started the problem, there was nothing in it that says u. Notice there's nothing. So I got to change it back to x. What is u equal to? X squared plus 1. So if you put it back in, to what power? 51 plus c. So that's how your substitution is going to work. Then try to change them so I don't have to multiply this 100 times. Let me try another one. X squared times x cubed plus 4 to the power of 8 dx. I can take the x squared because here's what I'm thinking about in case you're wondering what am I thinking. I'm looking at this. X cubed plus 4. What is the derivative of that? What's the derivative of x cubed plus 4? 3x squared. I got the x squared. You see that x squared? So maybe that's going to be part of the derivative. So maybe I should write this, rewrite it one more time. And let me let u equals what? X cubed plus 4. So right now I'm going to come down, leave a space there. I can rewrite that problem. Instead of x cubed plus 4, I'm going to make it what? U to the 8th. Well, I can't leave this x squared dx. If I put x squared dx, forget it. We doomed. So I need to change it. And to change that, we take the derivative of this. What is the derivative of u? It's called du dx. What's the derivative of that? 3x squared. So what is du? Isn't that 3x squared times dx? Darn it. I got the x squared dx, but this has a 3 in it. See that? If I had a 3 here, I'd be like, perfect. I don't have the 3. Yep, multiply it by 3 and divide it by 3. Or multiply it by 3 and put a 1/3 in the front. Would that change anything? What's 1/3 times 3? That's a 1. So there's my 1/3 in the front. But by doing that now, what is this piece equal to? Isn't that equal to du? See it? So I can replace all of that now with du. So now let's integrate it. There's the 1/3. Add 1 to the power u to the 9th over what? 9 plus c. That's 1 over 27. U to the 9th plus c. I got to change it back to x. What is u equal to? X cubed plus 4 to what power? To the 9th power plus c. So I guarantee you, if I take the derivative of that, I'll end up with that answer. Let's test it. Instead of going, yeah, sure, we believe you. But let's test it. Here's 1 over 27. What is the derivative of x to the 3rd plus 4 to the 9th power? It says 9 times x cubed plus 4 to what power? Power of 8, right? Times the derivative of what's on the inside, which is what? 3x squared. What's 3 times 9? Does it cancel 27 in the bottom? You end up with what? X squared times x cubed plus 4 to the 8th power. Is that what this one is? So that's one way of testing it. Taking the derivative of this should give me that one, and it does. Well, again, this method comes in handy. You'll see the next example I have in mind here.
I see why you like calculus 2 or calculus 1. Does it work on that?
Well, if you memorize all the derivative, yes, it is more fun. If you don't memorize them, then I go, oh no. There's more to it, actually. I'm just giving you just the first couple of sections in it. Without this method right now, I couldn't integrate this question. Without the use substitution or integration by substitution. I'm gonna rewrite this as first 2x minus 1 to what power? 1/2, and there's a dx. So I'm gonna let u equals 2x minus 1. Again, leave a space. So this problem now can be written as u to the 1/2. And let me wait on the dx. I need the derivative of this. What's the derivative of this? 2. What's du equal to? 2 times dx. Again, let's take a look back. Do you have a 2 in the front? No. No big deal. Multiply it by 2 here to make it match this one. And if you multiply it by 2, you better divide it by 2. Otherwise, you're changing the whole problem. So there's the 1/2 in the front. And instead of 2 times dx, I'm going to write what? du. One half, let's integrate that. Add 1 to the power, that's 3/2. Dividing by 3/2 is the same as multiplying by 2/3. That's indefinite integral, you got to add the c. 1/3 u to the 3/2 plus c. And the last step now is take the u out and put 2x minus 1. Again, if you want to test it, take the derivative of this. If you take the derivative of that, you should end up with that. Couple more examples on this. And I can make definite or indefinite integral these problems. It doesn't really change anything. Now that sine squared that you see here, that's nothing more than this, sine 3x the whole thing squared, like this. Cosine the 3x the dx. And again, if you're not sure which one's which, go, if I let u equal sine 3x, what is the derivative of that?
Cosine, or 3 cosine.
Yep, it's cosine 3x times the derivative 3x, which is 3. So du equals 3 cosine 3x dx. Almost perfect. Notice this here matches this. What's missing again? The 3. So multiply it by 3 to make it a perfect match. If you multiply it by 3, you got to multiply the front by 1/3.
Now, that always going to work out this nice, or is it going to be a little tougher, I guess?
All the ones we're going to give you, they should work out. If they don't work out, that means we have to look for a different method. So this becomes 1/3 the integral sine 3x, that would be u squared, 3 cosine 3x dx, that's du. That's u to the 3rd over 3 plus c, which is what? 1/9 u to the 3rd plus c. What is u equal to? Sine 3x to the 3rd plus c. You're probably not going to see it written like this. We never write it like that. You'll see it like this. That's the more popular look instead of that one. But that's what it means, the same thing. Yes.
So when you have like the inverse of sine, where it's like -1, sine -1.
Yep.
Is that really just sine 1 over sine?
No. Nope.
No.
That's actually,
Why did they mark it as that?
when you see sine to the -1, it's not the inverse. It's not actually 1 over sine.
Yeah.
That's the reciprocal. Sine to the -1 is the inverse of that. So for example, I say sine 30 degrees is 0.5.
Yeah.
When I go sine to the -1 of 0.5, can you tell me what angle has a 0.5 for a sine? And that's the 30 degrees. So that's the inverse function.
Why would they mark it as the inverse? But
No, they're right. If they want the derivative 1 over sine, they'll go 1 over sine instead of sine to the -1. Or the integral of that, you know. The question is sine to the -1. Does that mean 1 over sine? I said no. sine to the minus 1 on your calculus, the inverse function. And by the way, the integral is the inverse of the derivative. The derivative is the inverse of the integral. I can tell you when I'm teaching electronics, sometimes I have an equation that looks like this. And I want to solve it. I got a derivative, I got an integral, and I got this function. I do it all the time in circuits. If anyone takes my circuit class next semester, none of you probably be in it. Yep.
7b of t is not an integral at all.
They're all v sub t. I'm just lazy.
That's just the only integral.
No, that's no integral with this. That's just a separate one. So what we do to cancel the integral, we take the derivative of everything. So this becomes the second derivative. And the derivative of this becomes the first derivative. And when you take the derivative of the integral, they cancel each other out because they are the inverse of each other. And the problem turns like that. It's called a second order differential equation because you have a second derivative. That's actually the course called differential equation. How do you solve a problem like these?
What in electronics is defined by the derivatives and the integrals? The flow speed?
No, well, that's voltage across capacitors and inductors.
Okay.
The V equals LdI dt, I equals C dV dt for capacitor, you know. So that's where they come in. And the voltage is the integral of that. There is the opposite, the reciprocal, inverse. So I use that stuff all the time. When people said to me, boy, your calculus skill is not bad, I go, well, trust me, just because Calc 1 ends, that doesn't mean I don't use it. I'm constantly using it. I'm always nervous about you multiplying this out, foiling it out, so I try to make sure you don't do it. Again, I can rewrite this 1 minus 2x squared to what power? Negative 7 times negative 4x dx. I brought this to the top, made it negative 7. And what I like about this, just by looking at it, what's the derivative of this? Can you see it? What's the derivative of that?
Negative 7.
No, the inside. Never, don't worry about the 7, just the inside.
4x.
Negative 4x. Voila. That's how do you know which one's which? You let u equals 1 minus 2x squared. The derivative of that is negative 4x, or you can say du equals what? Negative 4x dx. This one's a perfect match with this. So now this problem becomes u to the negative 7, and negative 4x dx is actually du. So add 1 to the power and divide by the new power. And the last step again, change it back to x. In place of u, I'm going to put 1 minus 2x squared to the 6th power plus c. just heads up, a lot of times when you, especially when you have a definite integral, when you integrate, because I can make these definite integral. Notice if I give you this, I'll make the definite integral. Let's go from negative pi over 2 to pi over 2. And let's do sine 2x dx. Well, you can take the sine 2x and let u actually here equals just the 2x. What's the derivative of that? 2, or du equals 2 times dx. I don't have a 2 here in front of the 2x. I can make that a 2 and put a 1/2 in the front. So this will be 1/2 sine 2x, that's going to say sine of u times du. And now I'm changing my limit, right? My limit from x equals, I want to put x equals negative pi over 2 to x equals pi over 2 because I'm using u. I don't want you to get confused. Oh, that's u. I'm just saying that's the x value, not u. Okay, what function is derivative sine? Negative cosine, right? Since it's definite integral, I don't have to put the limits. That's negative 1/2 cosine, what was u equal to? 2x. And I want to go from negative pi over 2 to pi over 2. And let's see what's going on. Negative 1/2. This will be cosine 2 times pi over 2, is that pi? Minus cosine of negative pi. What's cosine of pi? Isn't that 1? What's cosine of negative pi? 1. My answer is 0. Well, the reason my answer is 0, just to give you an idea, if you graph that sine of 2x, that's what you're looking at. This area is positive, this area is negative. When you put them together, what are you going to have? 0. They're exactly the same size, matching. That's why my answer is 0. Because if you're above the x-axis, that's a positive area. And below the x-axis, that's a negative area. And since you're going from the same exact spot, this area will be identical to that. And one is positive, one is negative, you end up with 0 for an answer. So that's why your answer is 0. If you want to get the true answer, you don't care if it's below or above. Then you break it down from negative pi over 2 to 0, get the absolute value of that, then go from 0 to pi over 2 and get the absolute value. Or in this case, find the answer to 1/2 of it and multiply it by 2. That's a true area without counting the plus minus. But when they say go from negative pi over 2 to pi over 2, you have to say the answer is 0. They're not asking for the area.
Just a little bit, right?
Hmm?
You're a little bit off the screen. Just a little bit.
But in this case, that's why your answer is really 0, because you got a positive area and negative area, and they're canceling each other out.